Welcome to this Wise Owl Excel VBA tutorial. In this part of our series on writing SQL for Excel files, we're going to look at how to use aggregation functions. We'll start with a very quick example of summing a column using the basic sum function. We'll then explain what happens when you attempt to mix aggregated and non-aggregated columns, and then move on to some of the other basic aggregation functions such as count, min, max, and average. We'll have a brief look at the standard deviation and variance functions, explain how you can mix aggregation functions with other calculations, and then towards the end of the video, show you how to deal with nulls in your aggregates. So let's get started. If you've been following previous parts of this series, you'll be fairly familiar with the basic setup by now, so you may prefer just to skip to the next part of this video. If you haven't seen previous parts of the series, here's a quick look at the basic setup. We have a macro-enabled workbook called Aggregation Functions, and we have a button in here which we can click on to run a query. And when we do that, it's going to extract some information from a separate Excel file called Movies. In this video, the Movies workbook contains just a single worksheet called Film, and there's a list of 1200 films in that list. I'm going to keep that workbook open for the duration of the video just so that I can point out various things as we work through, but you can happily close down the Movies file and all of the code will still work. I have both of those files stored in the same folder. I'll drop a link in the video description so that you can download these files and follow along and write the code with me if you'd like to. A lot of the code that's in the Aggregation Functions workbook relies heavily on Microsoft ActiveX data objects, and that's not something I'm going to talk about much in this video. This series is meant to focus on the SQL side of things. If you are interested in how the ActiveX data object side of things works and how you can establish a connection to an external workbook and extract data from it, we have a separate playlist which covers that. And I'd recommend starting with this video here, How do I get data from a closed Excel file using VBA? Just to demonstrate the basics of how the code works, if I head back to the Aggregation Functions workbook, if I click the Run Query button, it's going to trigger a subroutine called Create SQL Query. And the only job of this subroutine basically is to construct a string which represents our SQL query. That string then gets passed into a separate subroutine called getQueryResults, and this is the one that creates the connection to the Movies workbook, extracts the data using a record set, and this is the point at which our SQL query gets used to set the source property of a record set object. And then there's a bunch of extra code in here which generates a new Excel worksheet, writes the data into that worksheet, and then does a whole bunch of formatting and tidying up. So just to demonstrate how the process works, if I head back to the menu sheet in the Aggregation Functions workbook, click the Run Query button, here I get my list of films and runtimes. The basic query we've just executed here returns one row for each film in the film sheet of the Movies workbook, so that means we can see each individual film's runtime. The first thing I'd like to do in terms of aggregation is show the total runtime for all the films in the list. And to do that, we can use a function that you're probably already familiar with, the sum function. It's pretty much the same sum function you'd expect from working in Excel. In fact, if I have a quick look in the auto sum drop-down list, we have access to the fairly standard range of aggregation functions in SQL as we do in Excel. So we can sum, average, count, max, and min. So to apply the sum function to the runtime minutes column in our query, let's head back to the Visual Basic Editor. And in fact, just in front of the f.runtime column reference, I'm going to type in the word sum, open some round brackets, close the round brackets after the reference to the runtime column, and then let's provide an alias to this column. Let's say as total runtime. And there's one other thing I will also need to do in order to make this work. Currently, I've got one column that's aggregated and one column that is not aggregated in the same select list. In SQL, you can't mix and match levels of aggregation like this. The film title column is still going to try to display all 1200 film titles, whereas the sum column is going to try to display the one single aggregated value. Now clearly I can't display 1200 rows against one single row, so we have to either aggregate the film title as well, or for this first simple example, just remove it. So I'm going to get rid of the film title column. And because this sum is now the first column in my select list, I'll also want to get rid of the extra comma sitting at the start of that line. Having done that, let's head back to the menu sheet in the Aggregation Functions workbook. head to the menu sheet, click the Run Query button, and I'll return just one single value that represents the total runtime of all 1200 films. So what would happen if we did try to include the title column next to the total runtime? Well, let's find out. Let's head back to the Visual Basic Editor, and in our select list we can include a new column. I'm going to add this just below my sum column. I'll add a new column that says f.title and then concatenate a continuation character. If I then head back to my menu sheet and I run this query again, I'm going to receive an error message. And the error tells me that the query doesn't include the specified expression title as part of an aggregate function. So essentially what that's saying is, if you aggregate one column in your select list, then every other column must also belong to an aggregate function. Of course, there are exceptions to that rule. You might want to include columns in your select list which aren't aggregated. So for example, rather than showing the total runtime of all of the films, you might want to display the total runtime for each individual genre in your movies list. So the total runtime for adventure and for action, etc. In order to do that, you'll need to include a group by clause in your query, and that's going to be the subject of the next video in the series. So for this video, we're just going to aggregate every column that we include in our select list. So what aggregation functions could we apply to the film title column to allow us to include it in this select list? It would be fairly pointless trying to sum the film titles, because how could you add Jurassic Park and Spider-Man and King Kong, etc.? But what we could do is count the number of film titles. So let's wrap the count function around the film title column. Put the film title column in some round brackets, and let's provide an alias. Let's say count of titles or number of titles. And then if we head back to the menu sheet and run this query again, we'll find a new column that tells us how many film titles there are in this list. When you use the count function to refer to a specific column, that counts the number of values in that column. So you'll see a little later on in the video that this can return different results depending on whether there are blanks or nulls in a column. As a way to shortcut this style of counting, rather than counting the values in a column, you could also choose to count the number of rows in your result set. So I'm just going to copy and paste the count line and paste it in again. I'm going to change the alias to say count of rows or count of results. And rather than saying count of a particular column, I'm going to replace the column reference with an asterisk. You may remember from previous videos you can say select asterisk to select every single column from a table. If you say count asterisk, that counts how many rows of data you've returned, regardless of whether there are blank values in any of the columns. So the end result of this select statement will be exactly the same as the previous one. We'll have 1200 rows and 1200 film titles. But again, as you'll see later in the video, this count might change when you reference columns containing nulls. Next, let's find the highest and lowest values in the runtime column. We can do that using the max and the min functions. So max gives you the highest and min gives you the lowest. Back in my VB editor, I'm going to copy and paste the original sum of runtime column and then paste that in towards the end of my select list, and then change my sum function to a max. Don't forget to include the extra comma at the beginning here as you're defining a new column. Or of course you could place your commas at the end of the previous line if you prefer that style. So I'm going to change the alias to say longest runtime. And then I'm going to copy and paste that line and change the function to say min, and then change the name to say shortest runtime. Having done that, I can head back to the menu sheet and run that query again, and I'll get the longest and shortest runtimes of the runtime column. You can also apply the max and min functions to text columns. If I head back to the Visual Basic Editor and I copy and paste these two lines, I'm then going to change the column name from runtime to title, and then we can update the aliases. It's silly to say longest title. I'm going to say max title, and then we can say min title. Then heading back to the menu sheet and running that query again. If you imagine your list sorted alphabetically by film name, you're seeing the film title that sits at the very end of the list and the film title that would sit at the very top of that list sorted alphabetically. The final one of the 5 basic aggregate functions allows us to calculate the average of a set of numbers. Let's just tidy things up a little bit first. If I head back to my menu sheet and choose to delete all but the menu sheet, then we can head back to the Visual Basic Editor and let's calculate the average runtime of all of our films. I'm going to copy and paste one of the previous columns which references the runtime column, paste that in at the end of my select list, and then change the function name to AVG, not the full word average, as you may be familiar with from Excel, and then we can change the alias there to say average runtime. Having done that, we can head back to the menu sheet and run that query again, and then we get the average runtime in minutes. If we want to apply some formatting or maybe round the number of decimal places down to 2, we can pass the results of the average function into another function. So let's head back to the Visual Basic Editor and we can wrap around the average function the round function. So we can say round average f.runtime, type in a comma after that and then say how many decimal places we want to use. So in this case I'll go for 2 and then close the extra set of round brackets for the round function, head back to the menu sheet and then run the query again and we get a slightly more neatly formatted output. There are also a few slightly more sophisticated aggregation functions which allow you to calculate the standard deviation and the variance of a range of numbers. Just to demonstrate those for the sake of completeness, I'm going to head back to the Visual Basic Editor and I'm going to take again one of my previous columns which references the runtime field and then paste that in just below. The first column I'll generate here will use the StDev, standard deviation function. And I'm going to change the name of my column to say runtime standard deviation sample. Then I'm going to copy and paste that line and change the function name to say standard deviation followed by a P, or StDev P. And I'll change the name of the alias to runtime standard deviation population. Then I'm going to copy both of those 2 lines and paste them in just below, and then change the function names to var, var, and var p, and then change the aliases from standard deviation to say variance, and then the same thing for the final column there. Okay, so having added in those extra columns, let's head back to our menu sheet and run that query again, and we get these extra columns containing the standard deviations and variances for samples and populations. Now, statisticians amongst you will know already intimately how those functions behave and what they're supposed to do. If you're interested in the maths behind this, there are several help pages on the Microsoft Office support website which explain how these functions work and shows you the formulae used to generate those. So I'd recommend having a quick read through those if you're interested in what these functions are actually designed to do. All of the aggregates that we've calculated so far involve all of the films in the entire film table. But it's possible to include a where clause in the same query to filter out the rows that you're not interested in. So let's say, for example, we only care about calculating this set of statistics for the Oscar-winning films in the database. If we head back to the Visual Basic Editor, we can happily include a where clause in our query by concatenating a continuation character and then adding the where clause. We've covered the where clause in a lot of detail in previous videos, so I'll just very quickly demonstrate here that we can say things like where the Oscar wins field is greater than 0. And then if we head back to the menu sheet and run that query again, we'll see a very different set of results this time compared to the list with all of the films included. So although the where clause sits further down the list in the select statement, so it sits below where we calculate the aggregations, the where clause actually applies before the aggregations get calculated. So all of these functions now only include the 254 rows where the Oscar wins value is greater than 0. You can happily include multiple criteria here. Let's say, for example, we wanted to apply this to only the fantasy films in our database. So we could include an extra criterion. We could add an AND operator and say where f.genre equals fantasy. And because fantasy is a string, it needs to be enclosed in some string delimiters. So in this case, I'm using single quote characters. Once again, if we head back to the menu sheet, we can run that query again and return a completely different set of details, this time based on all the criteria we've applied. You can use the result of an aggregate function to perform further calculations. Just before we demonstrate that, let's tidy things up a little bit first. I'll head back to the menu sheet and delete all but the menu sheet. Then back in the Visual Basic Editor, I'm going to get rid of a few of these superfluous columns. Let's get rid of the standard deviations and variances. And let's get rid of the min and max titles. And then I'm also just going to comment out the where clause for the time being. So one quick simple way to do that is to type in an apostrophe at the beginning of the ampersand symbol just before the where clause line. That will comment out everything after that point. So now that we've done that, we've got the min and max runtime values to give us the longest and shortest. I'd like to find out the range of runtimes by subtracting the minimum from the maximum. So let's add in a new column. In fact, I'm just going to copy and paste the max runtime column first. And then I can copy the min f.runtime and subtract that from the max to generate the runtime range. So I can say runtime range. And then if I head back to the menu sheet and I run that query again, I've got a new value calculated based on the results of two other aggregate functions. We could also use a calculation to provide the argument for an aggregate function. So let's say, for example, we wanted to calculate the average profit for each film. We could do that by subtracting the budget from the box office and then passing the result of that calculation for each row into the average function. So let's head back to the Visual Basic Editor and we can create a new column in our select list. So let's type in a comma at the beginning and we're going to use the AVG function. And we're going to first of all refer to the box office column. So we'll say f.boxoffice. And then from that we can subtract the f.budget. We then close the round brackets and provide an alias for the column. Let's call this one average profit. And then concatenate a continuation character to the end. We can run that query again from the menu sheet and we'll get the average profit for each film in the table. One thing to be aware of when using these aggregation functions is how they treat nulls in a column. We've just started referring to the budget and box office columns in our most recent calculation, and both of these columns contain lots of missing values or nulls. If I switch back to the movies workbook briefly, and then I head to the top of the budget column, tap the control key and the down arrow key, I'll stop just above the first empty cell or null. And there are lots of nulls in both the budget and box office columns, as you can see if you scroll a bit further downwards. So how do our aggregation functions treat those values? Let's find out by first of all performing a simple count of the budget field. If I head back to the Visual Basic Editor, I'm going to copy the line which counts the title column, and then I'm going to paste that in just below my count of rows. I'll change the column that I'm referencing to the budget column, and then change the alias to count of budgets. Having done that, we can head back to the menu sheet and run that query, and you can hopefully clearly see that the count of budgets is significantly different to the count of rows in the dataset and the count of title values. So we can see from this first example that the count function essentially ignores nulls in a column. And that's basically true for all of the aggregation functions, which can have implications if you're performing things like an average. Let's see what we get if we try to take the average of the budget column. If we head back to the Visual Basic Editor, I'm going to copy and paste the count of budgets field and then change the function to AVG and then change the alias to say average of budgets. So if I head back to the menu sheet now and I run that query, we'll see that we get a fairly large number. That's the average budget of films. But how is that being calculated? Is that the sum of the budgets divided by the number of rows in the dataset, or is it the sum of budgets divided by the number of budgets in the budget column? A simple way to find out is to perform both calculations the long-winded way. So let's head back to the Visual Basic Editor, and we're going to copy and paste we might as well copy and paste the average function, and then we're going to change the AVG to say sum, and then we're going to divide that by, first of all, the count of the budget column. So I'm going to copy and paste count of budget, and that's average of budgets 2. I can't think of a more inventive name for it than that. And then let's copy and paste that column, and then change the count to count the number of rows in the result set using the asterisk. We can then say average of budgets 3 because I'm out of inventive names apparently. And then if we head back to the menu sheet and run that query again, we'll see that the result we get for the AVG function is the same as dividing the sum of budget by the number of budget values. So it's the total budget divided by this value, not the total budget divided by this one. An alternative way to produce this same result as dividing the sum of budgets by the number of rows in the result set is to replace the nulls with an actual value. So we've seen how to do this in a previous video on dealing with nulls, but just as a quick recap, if we head back to the Visual Basic Editor, I'd like to find the average not just of the budget column, but the average of any nulls in the budget column replaced with a 0. So I'm going to start by copying and pasting the original average of budgets column, and I'll paste this in at the end of my ever longer list of average of budgets. You can probably guess what I'm going to change the name of the alias to. And then inside the AVG function, I'm going to open up an if function. So that's IIF, and then open up some round brackets. Just to make sure that I don't forget to close the round brackets at the end of this expression, I'm going to do that now. And then I'm going to make a copy of the f.budget column name and paste that in just inside the open round brackets. Now I want to check if the budget column is null. I have a couple of different ways of doing that. I could say after the reference to the column, I could say is null as 2 separate words. Alternatively, I can wrap the isNull function around the budget column. So I can say is null as all one word with no spaces between them, and then wrap the budget column in some round brackets. Either technique works. After that, I can type in a comma and say what value I want to use if the budget column is null. And in this case, I'll just use a simple 0. Then another comma, and then say which value you want to use if the budget is not null. Well, I just want to use the budget. So having done that, if I head back to the menu sheet and I run that query again, my average of budgets 4 will give me the same result as taking the sum of budgets, dividing it by the total number of rows in the result set. One other option for avoiding problems with nulls is of course just to eliminate them from the query entirely. So we can do that by adding the where clause and only returning rows where the budget is not null and the box office is not null. So to do that we could head back to the Visual Basic Editor and we can uncomment our where clause, and this time we want to refer to the budget column rather than the Oscar wins, and the criteria is going to say is not null. And f.boxoffice also is not null. So I'm going to copy and paste that and replace the reference to the fantasy genre. Okay, so having done that, we can head back to the menu sheet again and run the query. And this time we get a consistent output for all of our average budgets. They all now read the same thing because we no longer have any nulls in either the budget or the box office columns. So there we go, a brief summary of the basic aggregation functions you can use in your SQL queries. In the next video, we'll continue using these aggregation functions, but we'll include them within groups in our data so that, for example, we can see things like the average and total runtime for each genre or for each certificate or country, etc. So hopefully you're looking forward to that one. Thanks very much for watching as always. See you next time.